Hello, bacha log. Good morning and welcome to this beautiful session. We are going to talk about one short series. The basic aim of this series is to help, first of all, those students who are not, comfortable with Hindi part. So we are going to cover this entire series in total English. Number one thing, and this series, as we have mentioned here, this is one short series. It means whatever topic we are going to pick in one session, in that session, doesn't matter what is going to be the length of this video, in that video itself, entire topic will be covered better. So today we are going to look at the very first chapter of theory of machine, which is simple mechanism. And in this very short, crisp video, I am going to cover all important topics of simple mechanism chapter, which are going to be asked in GATE 2023. Acha, whenever I am going to teach you theory of machine ka this particular chapter in paid batches, so this is going to take at least 20 to 25 hours, not less than that. But again, exams are very close, and our focus should be only on those portions from where chances of getting questions is very high. So what are those topics which I am going to cover? Let's have a look. In this session, I am going to cover, first of all, majorly I will be covering degree of freedom of mechanism. What is the degree of freedom of mechanism? Grashoff's law, questions are asked here, beta. Inversions of mechanism. Then we will have a look at mechanical advantage, a very very small topic, but sometimes questions are also asked here. And then we have transmission angle, rarely asked, but again a very important portion. So these are the crisp content of this chapter which I am going to deliver here. Acha, before directly jumping into degree of freedom of the mechanism, let's understand what is the mechanism. Whenever we see around us, we are surrounded by so many mechanisms, so many machines. And in fact, Three Idiot movies, if you have seen Three Idiot movie, so Ranchor Das has also given example of machine, that anything which makes your life simple is called as machine, beta. Hai. So I think feeling everybody has what is machine. If you are looking up at your fan, this is also a mechanism, beta. If you are looking at the folding table of your house, that is also a mechanism. If you are looking at IC engine, this is also a mechanism, and in fact this is the mechanism which is most widely used in this entire world. Now, mechanism is made up of certain small parts which we are going to call it as kinematic link. What is the meaning of kinematic link, beta? Very careful. There is a very important part of mechanism which is known as kinematic link. By definition, it is defined as every small part of the machine or mechanism which is going to have relative motion with respect to some other part. Acha, look here at this IC engine. In this IC engine, how many parts you can see? I'm not asking you to count these nuts and screws also. I am asking you to count all those parts which are having some relative motion with respect to some other part in this particular mechanism. Let's have a look for a moment. Very easily you can see here, sir, there is one thing jisko we can call it as cylinder. This is my cylinder head, cylinder body, and this inside this cylinder body I am going to have one crank. This is the crank, and this crank can have rotation inside the cylinder, about this axis. So with respect to this cylinder, this is one link. Another link, which is crank. This crank can have rotation, relative motion is there. So crank will be considered as another link. Crank is connected to connecting rod. Between them, we are again having a pin joint. So between them, there will be some relative motion. Again, connecting rod I will consider as a separate link. And with respect to this connecting rod, I have connected a piston here, again with the help of pin joint. And this piston and connecting rod can have relative motion. So piston ko bhi I will consider as a separate link. So how many different links you can see here beta? You can see there are total 4 links. कौन से links है beta? This very first one which you are calling as your cylinder, this is your first link. Then we have this crank as your second link. Then we have this connecting rod as your third link. Then we have this slider or piston as your fourth link. These are going to be total 4 kinematic link which this IC engine is going to have. Now, in reality, this body is having this shape, beautiful shape. But in practical, we can represent this diagram as a line diagram, a schematic diagram. How? I'm not going to make this entire 3D beautiful diagram as always. I will simply show कि भैया I am having one link which I am calling as my cylinder or body of this engine, which I am going to fix with my frame or chassis of the vehicle. Now once this frame is fixed, I have just represented this by a fixed symbol. That's it. This is the symbol of fixed link. With respect to this link, we are having a crank which can have rotation. This is the crank which can have rotation. Pin joint ke saath. With this crank, I have again another link which I am calling it as connecting rod. Again, we are having a pin joint here, beta. And with this connecting rod, I am having a slider which is connected here again with the help of pin joint. Okay, and this slider is inside this piston, is inside the cylinder. So let me make the diagram. Bhaiya, this is my cylinder beta, cylinder head. है ना? The slider or piston can move inside the cylinder. Clear hai? This is again fixed link beta. This fixed, it is not different things. These are same thing. This is also fixed, this is also fixed. So this is entire one thing beta. Actually, you can see that this is in reality, this is one thing. But in my line diagram, I have shown some part of the fixed link here, some part of the fixed link here. But don't make this mistake that many people will count it. Ki bhaiya, this is link number 1, ye link number 2 hai, this is link number 3, and ye mera link number 4 hai. And sir, isko link, can I call it as link number 5? Na bata na, this is not link number 5. Ye link 1 hai, this is also link number 1. Getting my point? Acha. If you have got a clear idea ki what is mechanism, how we are going to represent that, and how we are going to make numbering of the links on that. Many people may think ki sir, always links are going to be some solid body or some rigid body. Ki sir, this cylinder is a rigid body. Inside that we have solid crank, solid connecting rod, and this rigid piston. It is not always the truth beta. It is not necessary that your kinematic link need to be rigid body. It is even if it is not rigid body, I can use it to transfer power or motion from one link to another link. For example, here, luckily, whatever kinematic links I have shown here, luckily all these links are rigid in nature. Rigid means they are solid. The deformation, whenever there is motion, relative motion here, so deformation in the links is very less. They seem to be rigid. Whatever you have seen, this cylinder, this crank, connecting rod, piston, everything is example of rigid link here. You may have rigid link, but sometimes even flexible bodies can also be used to transfer motion or power from one link to another link. For example, we have this belt and pulley drive. Now, try to consider how many links you can see here, beta. We have this smaller pulley which is rotating about some fixed link. Obvious baat hai. This is rotating about some fixed link. So this is fixed link ke respect mein. Your pulley is going to have rotation. Fixed wala link always we are going to call it as link number 1. Sir, this is link number 1. Link 1 ke respect mein this pulley is going to have rotation. This is my link number 2. And now again we have another pulley here. Again we have another pulley here. Sir, this is also rotating with fixed link. Fixed ko you have called as link number 1. So ye bhi, this is also going to be link number 1 also beta. है ना? Link 1 के respect में pulley is rotating. Link number 2. Link 1 के respect में another pulley. which I am calling it as link number 3. Link 2 का motion is getting transferred into link 3 का motion. Why? With the help of this belt. And this belt, because it is capable of transferring motion of link number 2 to link number 3, I will treat this belt as my link. But by nature, this is flexible. This is not rigid. So this is called as flexible link beta. So everybody knows that links may be rigid in nature. Sometimes link may be flexible in nature. Or even sometimes fluids ko bhi we can also use as links. Whenever fluid is being used to transfer motion or power from one part of the mechanism to the another part of the mechanism, from one link to another link. Now here, look here beta, closely. The example which I have shown here, what I am trying to show, कि भाई, we are having a cylinder. This is a cylinder beta, and inside that we have filled some liquid. यहाँ पर I have filled some liquid. This is the liquid beta. This is the liquid. From one part, sir, from where? This is the plunger. This is a plunger, single link. If you are going to apply certain small amount of force here, at this end, at this ram, you can lift a very heavy weight. Now, how many links you can see here, beta? कितने links दिखाई पड़ रहे हैं? How many links you can see here? The very first link is this one. ये जो cylinder है ना, I will call it as link number 1. This is something which I am going to call it as link number 1. This is my link number 1. This is fixed. Link number 1. Link 1 के respect में this plunger or this ram can have certain motion. This is something which I am saying as link number 2. ये मेरा, this is my link number 2. ये मेरा link number 2 है. Link 2 को you are going to apply some, link 2 को you are going to give some power. That means some force, some velocity. You have given some power, you have given some motion, and motion is getting transferred from this place to another link. This is link number 2. This is something which I am calling as link number 3. Link 3 is going to have motion. Link 2 ko you have given input. Link 3 pe you are going to get some motion. Why? Which part has transferred motion of link number 2 to link number 3? Sir, we have used fluid. This is fluid. Yahan par inside mein you can see there is some fluid which is part of this mechanism, and it is transferring motion from link number 2 to 3. So the fluid which is being used here, whatever fluid you are using, that fluid, I will call it as fluid link. Getting my point? So I think everybody has got a clear idea. Okay, sir, links can be of 3 types. 3 types. It may be rigid link, but not necessary that it has always to be rigid. Nah. It may be rigid body, it may be flexible body, or it may be even fluid. Getting my point? Now, you are going to connect links in certain order to get some kind of motions. So, cutting all these parts and directly coming to that particular portion from where questions are going to be asked. Questions में the very first thing, examination में simple mechanism chapter से, the very first thing which is going to be asked is degree of freedom of the mechanism. They will give you certain type of mechanism and they will ask कि भाई try to find out, try to calculate what is the degree of freedom. I'm not doing derivation part here, but let me give you a very important formula. Degree of freedom, first of all, what is the meaning of degree of freedom? Degree of freedom का मतलब होता है, this is something, if I tell you the raw definition of degree of freedom is the number of independent variable which is required to define motion or position of certain body which is having some motion. Any body which is having motion, and if I want to define its position or motion completely, so how many parameters I have to tell you? And from the point of view of mechanism, if you are talking what is the meaning of degree of freedom in the field of mechanisms, it is defined as number of inputs which is required to get constrained output. I will show you with one example beta. In the field of degree of freedom, one mathematician Sir Kuzbak has done a beautiful job. He has given a formula, but this formula which I am writing here, this is only for planar mechanism. Degree of freedom for planar mechanism. If we talk, why we are talking about planar mechanism? Because in our syllabus only planar mechanism is there, beta. Only planar mechanism. Planar mechanism में degree of freedom के लिए we have a beautiful formula which is 3l minus 1 minus 2j minus h. From where we have derived this formula, this we will see when we will talk about theory of machine course in detail. That's a different thing. But abhi ke liye, you have to understand what is the meaning of each and every term in this formula. In this formula, this L is denoting number of links. How many number of links you have? So you have to carefully calculate all the links which are present in the mechanism. Number one thing. Second thing, this is J. What is this? This is number of, actually I have written number of those pairs which are having degree of freedom 1. Number of pairs having degree of freedom 1, or also known as lower pairs, beta. Generally lower pairs are having surface contact, and they are going to show generally, mark my word, generally they are going to show 1 degree of freedom. On the other hand, this H is something which is number of pairs between the links having degree of freedom 2, and generally higher pairs are going to show this kind of nature, beta. If you can calculate carefully how many number of links are there, how many lower pairs are there, how many higher pairs are there, just put down all these values, and this formula is going to give you what is the degree of freedom ka value. Let me give you one example so that you will get more clarity how this formula is being used. Suppose for example I have a mechanism something like this. ऐसा कुछ mechanism नजर आ रहा है बेटा? Something like this. There are few links which are connected with the help of pen joints. Something like this. One link is fixed. This one is fixed. Try to count. And question में they are asking कि भैया for this mechanism try to find out what is the degree of freedom. कैसे निकालेंगे? Whichever is a fixed link, उसको I will call it as link number 1. This is link number 1. This is link number 2, and ये link number 3 है. This is link number 4. This is link number 5. So how many links, total links are there, beta? 5 links are there. How many lower pairs or binary joints are there? Sir, lower pairs. One lower pair is this. One lower pair is this. Turning pair, na beta? One lower pair is this. One lower pair is this. One lower pair is this. 1 degree of freedom wala pair. 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 Clear hai? So how many pairs are there? Sir, count kariye. 1, 2, 3, 4, 5. 5 lower pairs. Put down the value. Lower pairs. 5 lower pairs. There is no higher pair. Higher pair का मतलब होता है those pairs where you are going to have point contact or line contact. And there is no higher pair. Higher pair is 0. Carefully calculated these values and put down these values in formula 3l minus 1 minus 2j minus h. Put down these values. What you will get? 3 times l minus 1, which is 5 minus 1 minus 2 into j. J is how much, beta? 5 minus h. H is how much? 0. This is 4. 4 3 is 12. 12 minus 10. This is coming out to be 2. Degree of freedom comes out to be 2. Acha. For this mechanism, degree of freedom comes out to be 2. It means that in this mechanism, if you are willing to get constrained output, so you have to give input at 2 different lengths. If you can give one input here, input number 1, another input somewhere here, this is input number 2, then only you can get constrained unique output from here. Unique output. Getting my point? So what is the meaning of degree of freedom and how do we calculate it? Everybody has got a clear idea. Another example. Suppose, for example, if you are having a cam and follower device, है ना? This is a cam, fixed link के respect में this is going to have rotation, and there is a follower beta. इसके ऊपर you are having a follower. Follower looks something like knife edge follower is there. ऐसा कुछ दिखाई पड़ता है. This is something like this. And with respect to fixed link, it is also having sliding wala contact. How many links you can see here? This is another question. How many links you can see here? Sir, count करो बेटा. Fixed wala always link number 1. Link 1 के respect में cam can have rotation. This is my link number 2. Link 2 के respect में this link number, this follower is also having certain type of motion. इसको मैं बोलूंगा this is my link number 3. And again this fixed wala link is your link number 1. How many total links are there? Total number of links I can see. There are total number of links are 3. How many lower pairs are there? Sir, 1 and 2 के बीच में we are having turning pair. Here we are having turning pair. Lower pair. Surface contact. 3 and 1 के बीच में, between 3 and 1 we are going to have sliding pair. And sliding pair is again example of lower pair. Surface contact is there, na? So we are having two lower pairs where between 1 and 2 and 3 and 1, 1, 2 and between 3 and 1 we are going to have lower pairs. Surface contacts we are going to have. 1, 2 के बीच में we are having turning pair and 3, 1 के बीच में we are having sliding pair. Clear है? Do you have any higher pair here? Yes, definitely we have one higher pair. Link number 2 and link number 3 के बीच में you can see that we are having very less contact, point contact. This is your higher pair. How many higher pairs are there? Sir, there is only one higher pair. Put down these values in the formula. Degree of freedom F is equal to 3 L minus 1 minus 2J minus H. Put this value. L का value 3 है, J का value is 2 and higher pair का value is 1. Try to calculate what is going to be the answer. 3 minus 1, 2. 2 3 are 6. Minus 2 2 are 4. Minus 1. Answer is coming out to be 6 minus 4 minus 1. This is coming out to be 1. Degree of freedom का value you have got as 1 beta. Getting my point? So examination में they are going to ask questions. First question, simple mechanism chapter say the very first question, if question is being framed, so the very first question will be from degree of freedom wala part. They will give you certain type of mechanism and they are going to ask what is going to be degree of freedom of this particular mechanism. Clear है ना? Clear? अच्छा. Now, how do we calculate degree of freedom? Everybody is comfortable. Now, the equation which we have seen here, this equation, let me write down the name. This equation was given by, I have already mentioned, given by Sir Kutzbach, and that's why this equation is called as Kutzbach equation. Very important equation. This is used to calculate degree of freedom of any mechanism. Now, there was another mathematician whose name was Grubler. Keep this name in your mind. Examinations where sometimes they may ask, write down the Grubler's criteria, Grubler's equation. Grubler's criteria के बारे में we are going to discuss. What is this Grubler's criteria? Actually, he has done nothing. Grubler's भाई साहब ने क्या किया है? What they have done? He has taken Kutzbach equation. Kutzbach equation which was F is equal to 3L minus 1 minus 2J minus H, which we have just seen. अभी भी देखा है हम लोगों ने बेटा. He said, Grubler said, if there have to be any mechanism, if there is any planar mechanism in this world which is having degree of freedom 1 without any higher pair, with only lower pairs, Keep in mind, again I am repeating, if there have to exist any mechanism for any mechanism with 1 degree of freedom and no higher pair, only lower pairs की help से if you are going to form any mechanism of 1 degree of freedom, so that mechanism have to follow my criteria, and for that criteria what he has done is he has put these values simply in this Kurzbach equation, and this equation turned out to be how much? Degree of freedom की जगह पर if you will put 1 is equal to 3l minus 1, open करिए बेटा, 3l minus 3 minus 2j, h की जगह पर put 0 minus 0, so what you will get? 3l minus 2j, this one coming this side, minus 4 is equal to 0. This is the equation which we are going to call it as, this is equation Grubler's criteria. Keep in mind, this is something which is called as Kurzbach equation, and from Kurzbach equation Grubler has derived some another not so useful criteria, but still this criteria is in the books. Sometimes examination mein they may ask which of the following is the Kurzbach equation, option A, B, C, D they will give, and you have to select the correct option. Number one thing. Second thing, sometimes they may ask which of the following represents Grubler's criteria, option A, B, C, D. Some few things they will give, and few confusing things they will give. Yakin mano beta, when I was in my childhood graduation days, I used to be very confused. Options are so close, very close looking, they will give you options, option A, option B, option C. 3l minus 2j plus 4 is equal to 0, 3l minus 4j plus 2 is equal to, these kind of equations are they are going to give. Getting a point? So much close to each other, so you have to very carefully remember these things. What are these equations? Now, to satisfy this equation, this Grubler's criteria wala equation, minimum 4 links are required. With the 4 links, whatever mechanism you are going to make, with the 4 links and no higher pair, yani ki with 4 links, 4 links with 4 links and 4 lower pair, whichever mechanism you can get, those will be called as the simplest mechanism, because this is the minimum number of links which you have used here. If more than 4 links if you are going to use, maybe somebody has used, sir, I have used 6 links and I am also getting without higher pair, I have 6 link, some lower pairs, no higher pair, and sir, my mechanism is also giving me degree of freedom 1. What do we call it? You will call it as complex mechanism or compound mechanism, not simple. That will be termed as compound mechanism, or some people also call it as complex mechanism. Simple mechanism is this, which is having only 4 links and 4 lower pair, and only this thing is in your syllabus. In any examination, if you really want to crack that examination, you have to understand what are the dimensions of that syllabus. You have to understand the syllabus thoroughly, so that at least you must know the boundaries where you have to stop. Just because, sir, I am enjoying this subject, can you please teach me the complex mechanism? Na beta na. You have to control your emotions. Getting my point? So only simple mechanism is in your syllabus, and we will talk about only that thing. With the 4 links and 4 lower pair, whichever mechanisms you are going to get, those are called as a simple mechanism, which I have already written here. 4 lower pairs, 4 links and 4 lower pair, that mechanism is called as a simple mechanism. There are 3 kind of possibilities. Number 1, you may have 4 links, and all these links you may connect with the help of turning pair. 4 links, 4 turning pair. This is something which is known as a 4-bar mechanism beta. On the other hand, somebody is saying, sir, I will be having 4 links, but this time 1 turning pair ko I am going to replace with the help of sliding pair. Yani ki 3 turning pair, 1 sliding pair. All these pairs are lower pairs. 4 links, 3 turning pair, 1 sliding pair. This is called as a single slider crank mechanism. And if somebody is saying, "No, sir, again one more turning pair ko I am going to replace with the help of sliding pair," so this time you are going to have two turning pair and two sliding pair. This is something which is known as double slider crank mechanism. These are three examples. These are only three examples of simple mechanism. Only three kind of situations are possible, beta. Either you may have 4-bar mechanism, or you may have single slider crank mechanism, or you may have double slider crank mechanism. Nothing else. Everything we have covered. Now, थोड़ा सा, है ना, not much in detail, a little bit, let's have a look about what is a 4-bar mechanism and how does it look. Bete, 4-bar mechanism, let me write 4-bar mechanism, and whatever I am discussing now, believe me, whatever points, key points I am discussing here, examination make questions from only these topics they can ask. 4-bar mechanism. Very careful, beta. Very careful. Suppose 4-bar mechanism means you are going to have 4 links, sir. These are my 4 links, and all these 4 links ko I have connected with the help of turning pair. Sir, this is the pin joint, this is also pin joint, ye bhi ek pin joint hai, this is also pin joint, hai na? How many links you have? This is link number 1, ye link number 2 hai, this is link number 3, and this is link number 4. There are total 4 links. Count kar liye, 4 links, 1 2 3 4, 4 turning pair. 4-bar mechanism. Now, in this 4-bar mechanism, you can fix one link. Suppose somebody said, sir, I am going to fix this link. Your wish. Somebody is saying, "Nahi, sir, I will fix this link." Your wish. You can fix this link. Somebody is saying, "Nahi, sir, I will fix this link." Your wish, but you can fix any of these links. There are total 4 links. You can choose. You are free to choose which link you want to fix, and whichever link you have fixed. Suppose somebody has fixed this link. If you have fixed this particular link, I will say that this is my link number 1, which is fixed link, and fixed link ke adjacent, either this or this, any of the link ko you can give input, and from other you are going to collect output. Suppose somebody has given input here, this will be called as your input link. Fixed link ke another side mein you can have your output link. Okay? Fix any of the link, any one link, whichever you want. Once you have fixed certain link, so fixed link ke adjacent mein either this side or this side, any one side mein you can give input, from other side you have to take output. Clear hai? Whichever link which is connecting input to output, this particular link is called as your coupler link. Don't call it as connecting rod. Many people, many innocent children, they are calling it as connecting rod. Na bhaiya na, that is not connecting rod. Coupler boliye. Coupler बोल लीजिए, or you can call it as coupling rod. Connecting rod, this word we will use when it is part of your single slider crank mechanism, IC engine wala part, है ना? IC engine में we can use this connecting rod wala term, but till that time coupling rod or coupler, only this thing you have to use. अच्छा, sir, can you feel this input link? This is fixed about this point. This can have rotation about this point. Input link has no other option. It can have rotation about this point. Output link, similarly, output link can have rotation. Iske paas bhi there is no choice. It can also have rotation only. Both these links can have rotation only. Now, depending upon whether input wala link, it is capable of having complete rotation or not, और आउटपुट वाला लिंक इट इज हैविंग कंप्लीट रोटेशन और पार्शियल रोटेशन. देखो रोटेशन ही होगा, ओनली रोटेशन इज अ चॉइस फॉर इनपुट एंड आउटपुट लिंक. ओनली rotation is possible. Only rotation is possible. Now this rotation may be complete or incomplete, means it may be complete rotation or partial rotation. Only rotation, it may be complete rotation or it may be partial rotation or partial rotation or you can say incomplete rotation, or also known as oscillation beta. Getting my point? Partial rotation. Complete rotation का मतलब होता है if any particular link with respect to some center, if it can have 360 degree rotation, something like this, complete rotation. और partial rotation का मतलब होता है if it is having, sir, this is the link with respect to some fixed point, it can go up to this level and up to this level. That's it, sir. This, it is having motion something like this. Rotation hai, but this is not complete. At some point it have to stop. It cannot go beyond this. Majburi hai. Again it have to come back. It will stop at some point. Again it will go back. So between these two positions it is going to have motion. This angle, you know, between two extreme position is called as swing angle. क्या बोलते हैं बेटा? This is swing angle, and these two extreme positions are known as toggle positions. At toggle position, this link का angular velocity is going to be 0. Common sense वाली बात. These two end positions, extreme positions, are known as toggle positions. Keep this thing in your mind and please note it down somewhere that toggle positions पे link का velocity is going to be 0. That's it. That's it. Now, sir, how it will be decided that which link is going to have complete rotation, or when any link can have complete rotation? How can we decide? For this, Grashof has given a experimental law which is known as Grashof's law. It will help you to find out. It will help you to find out. Let me write Grashof's law. एग्जामिनेशन में पूछते हैं बेटा. Grashoff's law के बारे में we are going to discuss. What is the meaning of, what is Grashoff's law? Grashoff's law gives you a condition that for any 4-bar mechanism, लिख देता हूं मैं, this is only for 4-bar mechanism. Do not try to apply this law in single slider crank mechanism or double slider crank mechanism. Nah, but nah, this has limitation. This is only for 4-bar mechanism. And in 4-bar mechanism, depending upon which link you have fixed and what are the dimensions of other links. So these dimensions and your choice of which link you want to fix, this collectively will decide whether you can get crank or not. Crank का मतलब any link which can have rotation, you will call it as crank. Any link out of input and output, any link which is not having complete rotation, incomplete rotation, partial rotation, oscillation कर रहा है, that is something which you are going to call it as either rocker, or some people will also call it as lever. Now, when you can get crank this side or even this side, maybe some situations are there that input output both links are having complete rotation. So sir, can I call it as this is also my crank, this is also my crank? Yes beta, if both these links are having complete rotation, so both these links को you will call कि this is also my crank, complete rotation कर रहा है. This link is also my crank. Why? Because this is also having complete rotation. Both these links को you will call it as crank. ठीक है? If any of the link is not having complete rotation, for example, sir, only this one is having complete rotation, ये नहीं कर रहा है, this is crank, this is lever or rocker. Sir, none of the link is having complete rotation, this is also having oscillation, this is also having oscillation, क्या बोलेंगे? Sir, ये भी rocker है. Incomplete rotation, sorry, incomplete rotation, ये घूम रहा है, this is rocker. From here, something like this, it is having rocker वाला motion. This link is also not having complete rotation, तो ये भी rocker हो जाएगा बेटा. Getting my point? By fixing, sometimes by fixing this link, you may get both as crank. By fixing some other link, suppose you have fixed this link, now you are getting one link as crank, another link as rocker. Suppose by fixing another link, you are getting input output both as a rocker. So these, by fixing different links of any kinematic chain, you may get different type of motions, and all these different type of motions mechanisms are known as inversion. Examinations में sometimes they may ask, मैं लिख देता हूं another word, there is a term which is known as inversion बेटा. Just for your information, inversion का क्या मतलब होता है? Inversion means by fixing different links, by fixing different links. कॉमन सेंस वाली बात है, वन एट ए टाइम. ऐसा मत कर देना कि सर लिंक 1 को फिक्स कर दिया है, देन लिंक 2 को भी फिक्स कर दिया है, देन लिंक 3 को भी फिक्स कर. Either you can fix link number 1 or you can fix link number 2 or link number 3 or link number 4 one at a time. Link 1 को fix करो and then try to see which kind of motion is there. Link 2 को fix करो, try to see which kind of motion. Link 3 को fix करो, try to see which kind of motion. Getting a point? So by fixing different links, we may get different mechanisms. Mechanisms का मतलब होता है different kind of motions. Getting a point? These mechanisms, these different kind of mechanisms are known as inversion. We call them as inversion. Keep in mind, I have written we may get. There is no guarantee that by fixing different link you will get. There is no guarantee. No. By fixing different links, you will definitely get different type of mechanisms. I am not saying that. There are chances that by fixing this link, you will get some different type of motions, some different type of mechanisms. By fixing another link, हो सकता है whatever type of mechanisms you are going to get, this is exactly same which you have got earlier. So you will not count these as different inversions, but na. For if you want to say something as different inversion, it have to have different motions, different mechanisms. Getting a point? अच्छा, this is the basic thing बेटा. 4 bar mechanism के बारे में if we are talking, तो 4 bar mechanism में we may have these 3 inversions. Let me write inversion. Inversion of 4 bar mechanism. I will show with the help of animation also. Sir, you may have one possibility. Yes, sir. Input, output, both are some link you have fixed, and input, output both are behaving as crank. Both are having complete rotation. So this is called as crank mechanism. You may also call it as double crank mechanism. Sometimes by fixing some type of link, only one link can have rotation, other link is not having rotation. So one is crank, another is rocker. Crank rocker mechanism बोलते हैं बेटा. This is called as crank rocker mechanism. And हो सकता है sometimes rocker mechanism, both links are not having rotation, partial rotation कर रहे हैं. Rocker mechanism, this is called as rocker mechanism बेटा. Getting a point? Now, if you want to have continuous rotation, if you want to have continuous relative motion, if you want to connect motor, so bhai, at least one crank is needed. Can I write here? For continuous relative motion, at least one crank is needed. At least one crank. Both are crank, I am happy. But at least one crank is needed. Why? For continuous relative motion. क्योंकि rocker का basic behavior ऐसा है that rocker, if it is going to have motion, so rocker at some point of time it is going to stop. Again it will come back. And when it is stops, it breaks the motion. Again it will come back. At some position it will again stop. Break the motion. Again it will start moving, and at extreme position it will stop. Getting a point? So rocker का motion, it will stop at extreme position. Zero velocity, again zero velocity. Crank will have continuous rotation beta. These are the 3 possible inversions which 4 bar mechanism can have. Now, how do we decide? How do we decide that when you are going to get crank rocker, when you are going to get rocker rocker, when you are going to get crank rocker? Examinations में क्वेश्चंस पूछे जाते हैं बेटा. Grashoff's law, first of all, this is only for 4-bar mechanism, as I have already mentioned. What this law indicates? It indicates for continuous relative motion, for continuous relative motion, means for at least one crank, for at least one crank, links का length should be in such a way that summation of shortest plus longest link should not be larger than summation of other two links. It means if it should not be more than other two links का summation, तो फिर what are the conditions which may arise? Sir, less हो सकता है, equal हो सकता है. It may be less or equal than the summation, but greater नहीं होना है. Getting my point? So shortest plus longest link का summation should be less than or equal to p plus q. Getting my point? Getting my point? Clear है? अच्छा, this is the necessary condition, not the sufficient condition. मतलब if this condition is satisfied, उसके बाद you also have to check which length you have fixed. Then you will decide. If Grashoff's law is satisfied, if summations are in this manner, तो फिर you may get one crank or you may get two cranks, but at least one crank you may get. You may get. Again, it depends upon which length you have fixed. If some drastic length you have fixed, so even this may be the situation कि भाई Grashoff's law is satisfied and still you have whatever chain you have, that is Grashoff's chain, but still you have fixed some such a bad link that neither input nor output, anything, nothing is going to have complete rotation. Getting my point? ऐसी भी situations आती है बेटा. Now, let me give you one example. Suppose मान लेते हैं that if shortest plus longest length का summation is less than p plus q. बहुत ध्यान से समझना, ठीक है? Suppose I will just tell you the results and then I will show you some animation so that you can get a better feeling also here. Suppose beta, suppose this is the shortest link. This is the 4-bar mechanism. ये shortest link है. Sir, this is the shortest link. This seems to be the longest link, and this is P, this is Q. ठीक है ना? Careful. Suppose if Grashoff's law is satisfied and if you have fixed shortest link को fix कर रखा है, तो फिर shortest के adjacent both these links, this one will have complete rotation, ये भी complete rotation करेगा. You are going to get crank mechanism. Shortest को fix किया है, you will get crank mechanism. Let me write shortest को fix किया है, crank you are going to get. On the other hand, shortest के adjacent वाले link को if you are going to fix, तो shortest link तो complete rotation करेगा. This will have complete rotation, but this link will not have. This one is going to be input, this is going to be your output. Input link can have complete rotation, output link cannot have complete rotation, but this is going to be have as rocker. Adjacent to shortest को fix किया है, you will get crank rocker mechanism. And last, shortest के opposite वाले को fix किया है, this one. Shortest को you have made as coupler, opposite to shortest is fixed, you will get rocker mechanism. Sir, sir, एक link रह गया. Sir, please tell me that what if shortest के adjacent इसको fix कर दें तो क्या होगा? अरे same thing यार, adjacent to the shortest is fixed. Doesn't matter this side or this side. Either you can fix this or you can fix this. Result is going to be crank rocker. Shortest वाला link complete rotation कर जाएगा. Other link will not have complete rotation. Getting my point? Simple सी बात. अच्छा, whichever mechanisms are there which satisfy this law, Grashoff's law को satisfy करते हैं, those are known as Grashoff's chain. और Grashoff's chain में भी there may be one situation when shortest को you have made as coupler, you are going to get rocker mechanism. I will show the animation. Just wait for few more minutes. Another situation may arise कि sir, what if shortest plus longest equal to p plus q हो गया? Same thing यार, Grashoff's chain होगा and same logic से तो equality का भी sign में लगा देता हूं यहां पर. Shortest plus longest less than or equal to p plus q है. This kind of behavior you can see here. Examinations में they will ask question. They will give you some dimensions they will give and they will ask कि भाई find out which type of motion you are going to get. So you have to सबसे पहले you have to check कि whether this shortest plus longest का summation p plus q से कम है या नहीं. Many people are there, they will simply look कि सर shortest को fix कर रखा है तो फिर crank मिलता है. ना. If shortest plus longest, if this Grashoff's law is not satisfied, doesn't matter which link you have fixed, you can never get crank. नहीं मिल सकता बेटा. क्लियर है? अच्छा, one special situation, one special case. कि सर शॉर्टेस्ट प्लस लॉन्गेस्ट का समेशन p प्लस q के इक्वल हो गया है. सर ऑलरेडी यू हैव डिस्कस्ड इक्वालिटी वाला, you have already told that equality, whenever equality is there, you will have exactly same results. Nothing is going to change. But one special case, by looks, it is different. We are going to follow exactly the same thing. But how will it look? I'm just going to tell you that. Sir, what is so special here? Arey bhai, if you are having pair of equal length, array, what do I mean? I mean that suppose if mechanism is there which is having lengths 2 unit, 6 unit. Getting my point? There are 4 links, but links are in the form of pair. 2 unit, 6 unit. You may have 2 different kind of configurations. We will follow exactly these rules, but 2 special, by looks, 2 special configurations I am going to show you. Sir, very first one, which is known as deltoid linkage. Another is which is known as parallelogram linkage. Deltoid linkage, how does it look? Sir, छोटू सा link, another छोटू सा link, they are connected together. Shortest, and this is longest. Shortest together, longest together. Getting my point? This is something which is known as deltoid linkage. On the other hand, you may have कि sir longest link के साथ में we are having छोटू shortest link, longest के साथ में we are having shortest के साथ में again we are having longest, and then again we are having shortest. Now how they are connected, that's what I am showing. Shortest के adjacent में shortest, longest के adjacent में longest. One kind of configuration. Another configuration, sir longest के side में shortest, longest के side में shortest. That's it. These 2 configurations are known as, this is deltoid linkage. Sir ये pen joint है, this is also pen joint, this is also pen joint, this is also pen joint. Clear है बेटा? ठीक है ना? Rules are exactly same. Sir, any of the shortest को if you are going to fix, shortest either this or this, anyone. Sir, whenever shortest is going to be fixed, shortest को fix किया है तो crank मिलने वाला है. इफ एनी ऑफ द लॉन्गेस्ट, दिस वन यू हैव फिक्स्ड, तो फिर लॉन्गेस्ट को फिक्स किया है, एडजेसेंट वाला शॉर्टेस्ट कंप्लीट रोटेशन करेगा, एंड दिस लॉन्गेस्ट विल हैव क्रैंक रॉकर मैकेनिज्म। गेटिंग अ पॉइंट? इफ यहां पर इफ शॉर्टेस्ट को फिक्स किया है, क्रैंक मिलेगा, इफ लॉन्गेस्ट को फिक्स किया है, क्रैंक रॉकर यू आर गोइंग टू गेट। हियर पैरेललोग्राम लिंकेज में इफ लॉन्गेस्ट को यू हैव फिक्स्ड, सर ये शॉर्ट, both short link will have complete rotation. On the other hand, if any of the shortest को you have fixed, तो सर shortest के adjacent both links they are going to have complete rotation. इसका मतलब doesn't matter which link you have fixed here, either short or long, anything fix करोगे you will always get double crank mechanism. Getting a point beta? Now what I want to say is this. With the help of these animations, you can easily check. Sir, this is the Grashof chain. Shortest वाले link को you have fixed. तो input link, output link, both are having complete rotation. दोनों complete circle में घूम रहे हैं बेटा. Angular velocities same हो सकती हैं, नहीं भी हो सकती हैं. I'm not saying that angular velocities of input out. For that, I have not made any comment. Input link will have complete rotation, output link will have complete rotation. Whether both these are going to have same velocities or not, nothing I have said. Only complete rotation, that's it. As you can see, shortest link को fix किया है, input, output both are having complete rotation. Number one thing. Second thing, shortest के adjacent वाले को fix कर रखा है, shortest complete rotation कर रहा है, longest वाला, this is going to behave as rocker. You can see here another situation. Sir, Grashof chain है, shortest link को coupler बना दिया है, shortest के adjacent वाले को fix कर रखा है, neither input nor output, output both are behaving as rocker बेटा. Getting my point? अच्छा, what if Grashof's law is not satisfied? Grashof's law satisfied नहीं है, so you will get a triple rocker mechanism. अच्छा, what is the difference between triple rocker and double rocker? बेटे, feel the difference. This is non-Grashof chain. Non-Grashof chain. Input is also rocker, output is also rocker, और even this opposite वाला shortest link, ये भी आपको complete rotation करता हुआ दिखाई नहीं पड़ रहा है. Whereas here, in this case, input is rocker, output is rocker. But sir, opposite में shortest link, we cannot use it. But this is shortest link का motion, you can see this shortest link, complete rotation, it is having complete rotation. This is rocker. This is rocker, and this one is also rocker. So that's why we call it as triple rocker. ठीक है ना? Similarly, this is the example of parallelogram linkage. बट आप parallelogram linkage में longest के side में shortest कनेक्ट कर रखे हैं आप लोगों ने. Longest को if you have fixed, so you are going to get crank mechanism. Very easily you are going to get crank mechanism. Deltoid linkage का example. Sir, this is deltoid linkage. Either you are going to fix, longest link or shortest link. You are this is deltoid linkage where I have fixed longest link. Yellow color से we have represented shortest link. Longest को fix किया है, तो one link is going to have complete rotation, other link is going to have partial rotation, as you can see here. ठीक है? So that's enough. Concepts पे we have done discussion. I have shown you some animations also. Examinations के point of view से this page is going to be very, very important for you, everybody. ठीक है ना? Now, if you are comfortable till this point, now we can talk about single slider crank mechanism. And single slider crank mechanism, as I have already discussed, that we are going to have, again, simple mechanism का ही example है. We are going to have 4 links, but this time one turning pair को I will replace with the help of sliding pair, and this time I am having only 3 turning pair only, and 1 sliding pair will be introduced. Clear है? I have mentioned all the inversions, all the possible inversions which are, asked in examination. Inversion of single slider crank mechanism. something, it looks something like this. This is the, let me mention here, you may have, this is one link, we have another link, we have another link, something like this. This is the situation, sir. ये दिस इज योर लिंक नंबर वन, लिंक वन के साथ में विद द हेल्प ऑफ पिन ज्वाइंट टर्निंग पेयर के साथ में यू हैव लिंक नंबर टू, टू के साथ में वी हैव लिंक नंबर, दिस इज पिन ज्वाइंट के साथ में वी हैव लिंक नंबर थ्री, थ्री के साथ में दिस इज लिंक नंबर फोर, अगेन हैविंग पिन ज्वाइंट, एंड लिंक फोर एंड वन के बीच में वी आर हैविंग स्लाइडिंग पेयर. दिस इज सिंगल स्लाइडर क्रैंक मैकेनिज्म का काइनेमेटिक चेन. नाउ sometimes you are going to fix link number 1, you will get something. Sometimes you are going to fix link number 2, you will get something. Sometimes link number 3 को fix करेंगे, you will get something. अच्छा, link number 1 is something which you are going to call it as cylinder बेटा, यही आपका सिलेंडर होता है. Link number 2, this is something which you are going to call it as crank. Radius r से dimension को represent करते हैं. This is link number 3 which is going to be your connecting rod. Which is going to be your connecting rod, and this 4 is your slider, or sometimes people will also call it as piston beta. Slider बोल लीजिए, piston बोल लीजिए, nothing but same. If you will fix cylinder, you will get something. If you will fix crank, you will get something. If you will fix connecting rod, you will get some type of motion. If you will fix slider, you will get some type of motion. Examination में बहुत बार पूछा है, multiple times they have asked कि भाई cylinder को if you are going to fix, which kind of mechanisms you are going to get. If cylinder is fixed, you may either get IC engine or reciprocating compressor beta, depending upon input कहां दे रहे हैं and from where output you are going to collect. Cylinder को fix कर रखा है, input you are giving at piston, output you are collecting at crank. This is known as IC engine. Reverse कर दीजिए, input you are giving at crank with the help of motor, piston पे you are collecting output, you will get a mechanism which is known as reciprocating compressor बेटा. इसी को हम लोग reciprocating compressor भी बोलते हैं. अच्छा, somebody is going to fix crank, you will get Whitworth quick return motion mechanism or rotary cylinder engine. Somebody is going to fix connecting rod को fix कर दीजिए, you will get crank and slotted lever quick return motion mechanism or oscillating cylinder engine. If slider is fixed, you will get hand pump as your mechanism beta. Acha, out of all these mechanisms, just you have to remember, when we are going to get which type of mechanism. But examination के point of view से सबसे ज्यादा important is crank and slotted lever quick return motion mechanism. I will tell you how does it work and how questions can be asked here. बहुत ध्यान से बेटा. What is fixed here? Only one thing I am going to discuss. Where questions पूछे जाने के chances बहुत ज्यादा हैं. Only that thing I am going to discuss. Crank and slotted lever quick return motion mechanism. Clear है? In this short video, I will talk only about those things which are very, very important. And again I am saying, at the start I have mentioned, but again I am saying, otherwise this chapter is going to take at least 22, 25 hours approximately to get feel of this chapter. But I'm assuming कि भैया you have already studied theory of machine and now you are looking for revision, and this platform is going to be one stop solution for your revision. Clear है? So revision के point of view से I have covered only the very important things. ठीक है बेटा. क्रैंक एंड स्लॉटेड लीवर क्विक रिटर्न मोशन मैकेनिज्म कैसा नजर आता है? क्रैंक एंड स्लॉटेड लीवर क्विक रिटर्न मोशन मैकेनिज्म. वेरी वेरी केयरफुल. सर क्या फिक्स कर रखा है आपने? हाउ डज इट लुक? सर यू आर गोइंग टू हैव, दिस इज योर सिलेंडर, सिलेंडर के साथ में यू आर हैविंग, दिस इज योर क्रैंक, क्रैंक के साथ में विद द हेल्प ऑफ कनेक्टिंग रॉड, with the help of pin joint you are having connecting rod, and then you are having here, you are having, this is your slider. What is fixed beta? You have fixed your connecting rod. Connecting rod ko we have fixed. This is my link number 1. Link number 1 ke saath mein you are having link number 2. This is link number 3 and this is link number 4. Clear beta? Which kind of motion you are going to get? Let me show you that. Sir, acha, this is the idea. इन रियलिटी आई मे चेंज शेप, है ना। लिंक 1 को आई एम मेकिंग हेयर, ये लिंक नंबर 1 है बेटा, बहुत ध्यान से, ये दिस इज माई लिंक नंबर 1 विच इज माई कनेक्टिंग रॉड। लिंक 1 को यू हैव फिक्स्ड, इसको फिक्स कर रखा है, और लिंक 1 के एक एंड पे समवेयर हेयर यू हैव कनेक्टेड लिंक नंबर 2। एट दिस पॉइंट आई हैव कनेक्टेड लिंक नंबर 2। सर दिस इज माई लिंक नंबर 2, ये लिंक नंबर 2 है मेरा, दिस इज माई लिंक नंबर 2, लेट मी राइट, ये लिंक नंबर 1 है बेटा, दिस इज माई लिंक नंबर 2। 2 के एंड पर अगेन विद द हेल्प ऑफ पिन जॉइंट आई हैव लिंक नंबर 3। यहां पर पिन जॉइंट के साथ आई विल कनेक्ट वन लिंक विच आई विल बी सेइंग एज लिंक नंबर 3, ठीक है। 1 के अदर एंड पे पिन जॉइंट की हेल्प से यू हैव कनेक्टेड अनदर लिंक, लिंक नंबर 4, पिन जॉइंट की हेल्प से। तो लिंक 1 के अदर एंड पे पिन जॉइंट से आई एम गोइंग टू कनेक्ट अनदर लिंक, let me connect another link, और that link को I am giving some shape, I am free to give it shape बेटा, I am free to give it some shape। तो slotted link का I have given it shape, और इस link को I am connecting somewhere here with the help of pin joint I have connected। this is link 1 के साथ में another link which I have connected, let me show it by green color so that you will have a beautiful clarity beta। this link number 4 को I have given some shape here, ठीक है, this is my link number 4 बेटा। 4 and 3, where is link number 3? link number 3 is connected with link number 2, ये है, this is my slider, this is my link which I am saying as link number 3 बेटा। now check 1 2 के बीच में टर्निंग पेयर है, 2 3 के बीच में भी हैव टर्निंग पेयर, 1 4 के बीच में भी हैव टर्निंग पेयर, exactly same as I had here। लिंक 3 and 4 के बीच में आई हैव स्लाइडिंग पेयर, लिंक 3 4 के बीच में वी हैव स्लाइडिंग पेयर बेटा, ठीक है ना। इफ आई गिव इट सम नेम, दिस इज पॉइंट O, दिस इज पॉइंट A, दिस इज योर पॉइंट B, है ना। इफ यू आर गोइंग टू कनेक्ट मोटर हेयर which is going to rotate link number 2, so link number 2 will have rotation, where it will have rotation sir along this circle, ऐसे घूमता हुआ नजर आ रहा होगा, है ना। with the help with omega angular velocity it is rotating। when this link 2 will have complete rotation, so link 3 is going to have this link number 4 is going to have oscillation, it is going to have oscillation। and let me show you the extreme positions। extreme positions क्या हो जाएंगी बेटा, one extreme position you are going to have will be somewhere here tangential direction में, another extreme position you are going to have somewhere here, and these extreme position, corresponding to these extreme position, the location of crank will be, sir, crank will be sometimes here and it will be sometimes here, careful when your crank is somewhere here, this slider point B will be somewhere here, and this link it have to come to this point at this end, this is the toggle position, angular velocity is becoming 0 here, again crank is rotating with omega angular velocity and it has moved somewhere here at this location, this link it will come traveling this entire distance, it will come here and again stop, again from this position when your crank again will rotate at this position, again this slotted lever will come back to this position beta। now everybody can see sir, motor if you have connected here, so from this position which I am saying as B1 position, from B1 position to this B2 position, this crank has traveled certain amount of angle which is I am saying as beta angle, which seems to be larger as compared to when the same crank will travel from B2 to B1 position in this direction beta, this is something which I am saying as alpha angle beta। can you feel sir, crank constant angular velocity से rotate कर रहा है, so it will take larger amount of time to travel this larger amount of angle, and this larger time when it has traveled from this position to this position, this slotted link will travel here. And again, crank constant velocity से small angle travel कर रहा है from this position to this position. Slotted lever को again it will have to come back from this end to another end. Can you imagine कि sir this angle seems to be larger because this beta is more than alpha. That's why you can claim कि sir if you look at the motion of this particular link, ये वाला जो link है, link number 4, इस link का motion it is going to have quick return type of motion. Quick return का मतलब होता है from one end it will come here, it will take larger amount of time, but returning में it will be fast. Getting my point? Examination में they will ask questions कि भाई tell me what is the quick return ratio. Quick return ratio, it is defined as ratio of this beta by alpha, है ना? And from this diagram easily you can check, you can easily tell कि भाई beta is more than alpha, यानी कि beta by alpha की value more than 1 दिखाई पड़ रही होगी, and that's why we call it as quick return motion mechanism. Quick return, cutting time ज्यादा है, return time is less. Cutting slowly it is doing, and return it is doing fast. Getting my point? But examinations में whenever they are going to ask question, but this is not going to be a question of theory of motion, this is going to be a question of simple geometry. What do you have to do? Simply make this geometry. Extreme positions बना लीजिए. And once you have made extreme position, so from this geometry you can easily calculate how much is alpha, how much is beta. Acha, one important relation let me tell you, it will help you to find out alpha and beta. Sir, quick return ratio is beta by alpha. And one more thing you can see, sir, beta plus alpha, this is nothing but 360 degree. Common sense वाली बात है बेटा. Now examination में sometimes they will give geometries. They will tell you कि भाई how much is the dimension of this link, fix वाला link, crank का dimension क्या है. They will give you these values, है ना? अच्छा, if extreme positions you can see clearly, can I say sir this is the tangential, this is the radius and tangent के बीच में we are going to have 90 degree का angle. So can I say how much is this angle beta? ये angle कितना है? This is going to be 90 degree. And if this is 90 degree, look at this triangle beta. From this triangle, can I say sir this is 90 degree, this half angle will become alpha by 2. ये भी लिख सकते हैं बेटा. This half angle is nothing but alpha by 2. So from this right angle you can easily find out how much is alpha by 2. Dimensions, if you know the dimensions, examination में dimensions sometimes they will give. If you know how much is this dimension, if you know how much is this dimension, so from this right angle triangle can everybody easily find out how much is alpha by 2. Alpha by 2 का value once you know, तो alpha पता चल जाएगा. Once you know the alpha, beta पता चल जाएगा. You will get to know how much is beta. Beta is known, alpha is known. Very easily you can find out quick return ratio. Getting my point? Either they will give the dimension and they will ask कि try to find out how much is the quick return ratio, या फिर sometimes reciprocal, they will give you the quick return ratio and they will ask how much is the dimension of missing link. Clear है बेटा? Geometry, simple geometry वाला problem है, but if you can identify these configuration extreme positions को identify कर पा रहे हैं तो very easily you can solve it बेटा. Very easily you can solve it. ठीक है? Most of the time questions, whatever questions they have asked questions about crank and slotted lever quick return motion mechanism only. Clear है ना? And that's why I have discussed this. Otherwise there are few more types of quick return motion mechanism, but again questions are not asked, so I will be limited to, I will you know to make this video very short and crisp, I'll be limited to only those points, only those parts from where you know chances of getting questions is very high. Acha, before concluding, let me tell you another important thing. We have double slider crank mechanism also. 4-bar mechanism we have seen, single slider crank mechanism we have seen, then we have double slider crank mechanism. And how does it look? Double slider crank mechanism कैसे नजर आता है? अच्छा, before we proceed, let me show you the animation also, so that you can get more feel. सिंगल स्लाइडर क्रैंक मैकेनिज्म में crank and slotted lever quick return motion mechanism. Just try to feel the motion, how it is moving. With respect to fixed link, this is the fixed link. Fixed link में about one point a link is there which is going to have oscillation. About one point a crank is going to have rotation, and crank के end पे there is a piston, there is a slider which is connected. ठीक है ना? Crank rotate कर रहा है with the help with constant angular velocity, and look at the motion of this slotted bar. Slotted bar slowly जाता है, fast it is coming back, slowly it is moving ahead, fast manner में it is coming back, slowly it is going this side, fast manner में it is coming back. That's why I am saying that this is your quick return motion mechanism, and this kind of mechanism you are going to use in many applications. Shaper machine, if you have seen, we are going to use this. Planar mechanism, we are going to use this. Clear है बेटा? ठीक है ना? चलो, let's proceed for double slider crank mechanism. क्या होता है double slider crank mechanism बेटा? You are going to have again 4 links, because we are talking about simple mechanisms. So 4 links and 4 lower pair, but this time 2 turning pair, and we are going to have 2 sliding pair. How does it look? How does it look? We are going to have a slotted plate, something like this. This is single link beta, single link, slotted plate. Shape ऐसा है. This is link number 1. Link number 1 के साथ में we are having a slider, which I am saying as link number 2. Slider के साथ में we are having link number 3. Pin joint के साथ में. Link 3 के साथ में pin joint के साथ we have link number 4. And 4 is again making sliding pair with link number 1. बहुत ध्यान से, careful. Link number 3 is having pin joint here, pin joint here. So between 2, 3 and 3, 4 we are having turning pair. I have mentioned here 2, 3, 3, 4 we are having turning pair. Between link 2 and link 4, with this link slotted plate, link 4 can have sliding in horizontal, link 2 can have sliding in vertical arm. Clear है बेटा? Clear है? How will it look during motion? Something like this. कुछ something like this. One, this red वाला link slotted plate which I am saying, this is single link बेटा. ये मेरा single link है. ठीक है ना? Inside this we are having 2 sliders which I have connected with the help of a link with the pin joints. Clear है ना? Now, again, you may have choices. Here also we can talk about inversions. You may have choices. Either you can fix link number 1 or slider. Either you fix this slider or this slider. Nothing but same बातें हैं बेटा. Link 1 को fix करेंगे, you will get something. Link 2 or 4, any of the slider you will fix, you will get something. If you will fix link number 3, you will get something. Slotted plate को if you are going to fix, you will get elliptical trammel. This is something which is used to draw ellipse. Ellipse को draw करने के लिए slotted plate को fix करेंगे. Let me show you. Slotted plate को if you have fixed, slotted plate is not moving. इसको fix कर रखा है. Other links are going to have motion. One slider is moving up down, another sliding is moving left right, and the link which is connecting to the sliders, on that link, if you take any points ka path, any point, connect pencil to that, so it will trace a ellipse. Getting a point? So this is something which is known as elliptical trammel. To draw ellipse, we are going to use this instrument. Then we have any of the slider ko if you are going to fix, koi slider, link 4 or link 2, nothing but same. You will get Scotch yoke mechanism, and this is something which is used to convert rotation into reciprocation. You can see, sir, link number 1 which is fixed. Link number 1 which is fixed. 1 के साथ में we have link which is going to have rotation. Slider लगा हुआ है ना? Rotation को it is converting into reciprocation. This is also known as a simple harmonic motion generator beta. And last, if rod which is connecting the slider, this is the rod which is connecting both these sliders. If rod को you are going to fix, so link 2 and link 4 के rotations can be transmitted into each other. If link 2 को somebody is going to rotate, link 4 will rotate in the same direction with the same velocity. And this concept is used as Oldham's coupling to connect shafts better. To connect shafts, you can see here. You can very easily see here. क्लियर है ना? चलो, इफ एवरीबडी इज कंफर्टेबल टिल दिस पॉइंट, थोड़ा सा और आगे बात कर लेते हैं. एज प्रोमिस्ड, टुडे वी विल बी कवरिंग डिग्री ऑफ फ्रीडम के बारे में बात करेंगे. वी हैव डन ग्राशॉफ्स लॉ, वी हैव सीन इन्वर्जन ऑफ मैकेनिज्म, वी हैव सीन. नाउ वी विल टॉक अबाउट टू very small but very important topics. What is mechanical advantage and what is the transmission angle? How do we define mechanical advantage beta? सबसे पहले let's have a look. What is the meaning of mechanical advantage? Beta, mechanical advantage is defined as ratio of output effort, output में how much force or torque you are going to get divided by input effort. Input में how much force or torque you have applied, you have given. Keep in mind, mechanism में it is not generating power. You are going to give the power at certain link and it is getting transformed from one link to another to another to another, and last में you are going to collect the output. Input में whatever power you have given, exactly same power output link से you can collect, but during this transmission from links, this power, this motion has transferred. So in this transformation some format में change सर हो सकता है. इनपुट में you have given some torque, some omega, torque into omega, this is power input you have given, but input में you have given very high velocity but very small amount of torque. But output में when you are collecting it, output link में you can see you will get some output some torque into omega, but output में हो सकता है whatever power you have given, this power it will be exactly same as output torque. Let me write it somewhere. ऐसा लिख देते हैं बेटा, whatever power you have given, output में exactly same power you are going to get. Input में जो power दिया था same power आपको you are going to get in the output also, but output में आते आते maybe angular velocity is very very less, but torque has increased. This product have to be remain same. Obvious बात है, whatever is the input power it will be exactly same as output power. Input torque into omega power, output torque into output omega power, these powers are same. Power का format change हो गया है बेटा. Getting my point? Power का format change हो सकता है. And this ratio output का effort divided by input का effort. Effort मतलब in terms of torque if you are talking, torque in terms of torque. In terms of forces if you are talking, torque in terms of forces only. आउटपुट में इफर्ट मिल रहा है, आउटपुट का टॉर्क डिवाइड बाय इनपुट में इफर्ट, इनपुट का टॉर्क. दिस रेशियो इज कॉल्ड एज मैकेनिकल एडवांटेज. क्लियर है? कैन आई राइट आउटपुट टॉर्क अपॉन इनपुट टॉर्क, आउटपुट टॉर्क अपॉन इनपुट टॉर्क को रेसिप्रोकल ऑफ वेलोसिटीज लिख सकते हैं. इनपुट ओमेगा डिवाइड बाय आउटपुट का ओमेगा लिख सकते हैं बेटा, है ना? नाउ वन वेरी इंटरेस्टिंग थिंग्स, वन इंटरेस्टिंग फैक्ट, यू विल बी सरप्राइज्ड. सर जनरली वी वांट कि मैकेनिकल एडवांटेज शुड बी मोर देन वन. वी वांट इट मोर देन वन होगा तो वी विल एंजॉय कि इनपुट में वेरी स्मॉल अमाउंट ऑफ टॉर्क आई विल गिव, आउटपुट में वेरी लार्ज अमाउंट ऑफ टॉर्क हमको मिल जाएगा. वेरी स्मॉल विद वेरी स्मॉल एफर्ट, वेरी heavy work we can do at the expense of speed. I can understand, but very small amount of force, if I'll apply force by this little finger, I can even raise 1000 kg weight with the help of my this little finger. That's a different thing. I will have to apply force with large velocity, but output may with very small velocity that heavy weight will be lifted. Clear है ना? अच्छा, one interesting thing is sometimes a situation may arise. For example, if you are talking about 4-bar mechanism, which is crank rocker mechanism. This is crank and this is going to be your rocker beta. ठीक है ना? You have given input here, motor you have connected, and you are going to collect output here. it is very important for me to tell you कि which is my input link, which is my output link. क्योंकि input का omega divided by output का omega, this is going to give you the formula of mechanical advantage. If I say output I am collecting here, the formula will be reversed. Getting my point? Everything will change. So very carefully you have to write कि whichever is your input link, उसका angular velocity you have to write here. Getting my point? Result, otherwise result reverse हो जाएंगे बेटा. Now this is the crank. You have connected motor. Can you feel motor connect कर रखी है? Motor is going to rotate with constant omega. Omega constant rotate कर रहा है. Continuously it is going to have rotation. Whereas the rocker, it is going to have oscillation वाला motion. Sir, at this extreme position, it is going to stop. These are the two extreme position. Between this rocker is going to have motion beta. And can you imagine at this toggle position and this another second toggle position, there are two toggle position, and at this toggle position output का angular velocity is going to be 0. बेटे, input omega is always constant and output का omega will become 0 at some position, not always but at some position, at whatever moment input में speed is there, output का speed 0 हो गया. Imagine करिए, input में speed is there continuously, output का omega is 0, something upon 0 you will get infinity. And that's what examination में multiple times they have asked कि at toggle position what is going to be mechanical advantage. Mechanical advantage at toggle position becomes infinity. Getting a point? At toggle position mechanical advantage will become infinity. But keep in mind, input is this, output is this. If I do it reverse कि सर input I am giving here, output यहां पर मिल रहा है, तो फिर ये infinity नहीं, फिर ये reverse 0 आ जाएगा बेटा. क्योंकि at certain toggle positions input का speed 0 हो जाएगा. Input will become 0, output continuous मिल रहा है, input will be 0 at toggle position. Input 0 होगा तो सर 0 upon something, this is 0. So very carefully, most of the time they have asked question कि at toggle position what is going to be mechanical advantage. Infinite आता है. But if very clever manner में if I say that this is my input and this is my output, तो फिर answer will be 0, not infinity बेटा. Clear है ना? ठीक है, चलो last topic for this session, the last topic. I hope everybody has enjoyed. Transmission angle. Recently, they have started asking about this. We will not go into much detail. Let me just give you a glimpse कि भैया what is the transmission angle. Suppose 4-bar mechanism के बारे में if I am saying, at any instant when I saw links of my mechanism were having motion something like this. Links of my mechanism are having motion like this. This is my fixed link. Okay. This is my input link. I have connected motor here. This is my input link. At any instant when I saw my input link was making some angle theta. Input angle बोलते हैं बेटा. This is called as input angle. Theta is input angle. ठीक है. Fixed link and input link के बीच में whatever angle you have, that is called as your input angle. Coupler, this is your coupler, and this is your output link. At any instant, coupler and output link के बीच में whatever is the angle, that is something which is known as transmission angle. Mu is called as transmission angle. Getting my point? Now, examination में sometimes देखो, if they have asked, generally they won't ask कि भाई at any position try to find out how much is the transmission angle with the help of simple geometries. All these dimensions they will give. They will tell you कि this is the dimension A, this is the dimension B. They will tell you all these dimensions. this is the dimension C, this is the dimension D. All these dimensions के बारे में they will give, है ना. Most of the time they will ask कि भाई for this mechanism ट्रांसमिशन एंगल का मिनिमम वैल्यू एंड मैक्सिमम वैल्यू बताओ, हाउ मच इट इज गोइंग टू बी. ठीक है, तो अगेन डेरिवेशन वाला पार्ट आई एम स्किपिंग, जस्ट गिविंग यू रिजल्ट्स, याद कर लीजिएगा. एंड आई मेनी ऑफ यू ऑलरेडी नो अबाउट दिस. ट्रांसमिशन एंगल इट इज नॉट इंडिपेंडेंट थिंग, इट विल डिपेंड अपॉन थीटा. थीटा का वैल्यू व्हेन इट इज 0 डिग्री and 180 degree. These are the two positions when your transmission angle is going to have minimum and maximum value beta. Clear hai? So whenever if they are asking, if they have given you a mechanism and they are asking try to find out what is going to be mu minimum value, mu maximum value, तो theta की 0 and 180 degree की values के corresponding you are going to get mu minimum and mu maximum beta. Formulas, there is no such formula. Many people might have remembered few things ki sir this is the formula, na beta na, there is no formula here. 0 degree wala configuration if you will draw very easily, sir 0 degree mein how this mechanism is going to look, sir 0 degree mein how this mechanism is going to look. Let me give a little bit color combination so that it will be easy for everybody to understand this. Listen carefully. For 0 degree वाला configuration, how will it look? Sir, 0 degree में it will look something like this is the white color वाला link. When theta is 0, this link का position is somewhere here. It will be, sir, ये है, अरे 0 degree वाला position, you are going to have this position बेटा. ये पिन जॉइंट है. इनपुट लिंक इज मेकिंग 0 डिग्री एंगल एंड देन वी हैव कपलर एंड आउटपुट लिंक. दे हैव नो अदर ऑप्शन, दे आर गोइंग टू मेक, दे हैव टू मेक अ ट्रायंगल समथिंग लाइक दिस. ऐसा कुछ नजर आएगा बेटा. दिस इज थीटा 0 वाला पोजीशन, दिस इज पिन जॉइंट, दिस इज पिन जॉइंट. कैन यू सी दिस वाज द गिवन मैकेनिज्म. थीटा की 0 वाली पोजीशन, वन पोजीशन यू हैव सीन. हियर यू विल हैव म्यू का मिनिमम वैल्यू. All these values, these dimensions they have given. ये dimension पता है, ये dimension पता है. This is ये dimension also known to you, है ना. All these dimensions are known very easily. You can identify this is mu minimum. Very easily you can find out how much is the value of mu minimum. कैसे निकालेंगे बेटा? Again let me tell you. This dimension is given. This dimension is given. This dimension is given. This is also given. That means you also know this dimension बेटा. So in this triangle ये dimension पता है, ये dimension पता है. This dimension is known. All three dimensions are known. Mu का value they are asking. Cosine rule का use करके very easily you can find out. And how do we use cosine rule? Please don't ask this, है ना. Please don't ask this. अरे बेटा, this is angle A, this is angle B, and this is angle C. Opposite to angle A we have dimension A. Opposite to angle B we have dimension B. Opposite to angle C we have dimension C, small c. Cosine rule says भैया cos angle A, if this angle you have to identify, cos angle A can be written as B square plus C square minus का opposite वाला dimension A square divided by 2BC. If all these dimensions you know, तो angles को easily we can find out बेटा. Clear है ना? So just draw the configuration. One configuration I have drawn for theta is equal to 0, and similarly for theta is equal to 180. What you will have? Sir, ये fix वाला link है. For 180 degree, input link will be somewhere here. ये this is your 180 वाला link. Input वाला link at 180 degree. Other two links they have no other option, sir. They have to make a triangle, beta. They have to make a triangle. It will look something like this. ऐसा नजर आ रहा होगा बेटा. ठीक है ना. दिस इज पिन जॉइंट, दिस इज पिन जॉइंट. ये भी माय डियर दिस इज पिन जॉइंट, एंड दिस इज द पोजीशन थीटा 180 डिग्री के करस्पॉन्डिंग, एंड दिस एंगल इज योर म्यू मैक्सिमम बेटा. सिंपल सी बात. अगेन यू हैव टू डू व्हाट? सर इन दिस ट्रायंगल ये डायमेंशन पता है, दिस इज नोन, This entire dimension is known. ये link, everything you know. Mu maximum पूछ रहा है, very easily we can identify बेटा. So sometimes transmission angle maybe they may ask questions. Clear है? That's all. So what we have seen here in this entire chapter, what we have seen examinations where degree of freedom pe they will ask question. We have seen what is the formula and how do we use that. Grashoff's law, what is Grashoff's law, how do we use that? We have seen that. Inversion of mechanism mein I have told you some inversions of mechanism. How do they look? Animations mein I have told you that. And examinations ke point of view se wherever numericals can be asked, I have discussed that. Mechanical advantage and transmission angle pe bhi we have had a very crisp discussion beta. So I hope you have enjoyed this session. I hope you have learned something. I hope it has helped you in revision part also. So thank you, and in the next session of this one short series we will meet and we will discuss some beautiful concept of velocity and acceleration analysis. Thank you bachcho, love you all.